a exclusive series. Okay, when we say exclusive series, in an exclusive series, excluding the upper limit of these classes of the class, okay, all other elements are included. I'll write it for you people, then I'll make an example. Excluding the upper limit of the class, all the items of the class are included, okay, in the class itself. When we are now talking about upper limit, lower limit, class, now you people are able to understand what I am talking about. For example, let us say marks, number of students, okay. So our marks are 0 to 10, 10 to 20, 20 to 30. These are classes with some class intervals, midpoints. Now you know what I am talking about. 30 to 40, okay. Let us say there are 2 students in this category, 5 students in this category, 2 students in this category, 1 student in this category. Okay, this is a table of yours. I made it in the horizontal shape. Got it? So what I mean, excluding the upper limit of the class, all items of the class are included. That means if I have to include the items from the any data, I'll take 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19 elements pertaining to these numbers. 20 will be put to the next class. 20 will be calculated in this very class. Now this next class. Here I'll take 0, 1, 2, 3, 4, 5, 6. Here I'll take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 will be calculated here. Here I'll take 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 will be. This is called the exclusive series. One more is called as the inclusive. Second or B is your inclusive series. Okay, dear students, please bear it in mind. We ask a question sometimes, convert this exclusive series into inclusive series, or what is exclusive series, what is inclusive series. So inclusive series is that upper limit of classes are included in the respective classes. So that means upper limit will be taken or calculated, included in the same class. I'll give an example. Again, marks, number of students, 0 to 9, what is next, 10 to 19, 20 to 29, okay. To 5 to, this is our table. What I am doing, upper limit of the class are included in the same class, in the respective class. See, we will take, if I have to take something from this class, I'll take 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 also. While in the exclusive series, we do not take 9. 9 will be taken in the next class. But here we take upper as well as lower. And in 10 to 19 class, what I'll take? Every element which comes from 10 to 19. That means including 10 and 19. 10, 11, 13, 14, 15, 16, 17, 18, as well as 19. That is what is the difference between inclusive series and exclusive series. There is one more thing you must learn, which is called an open-end class. Open-ended class. It just came into my mind. I thought that you must know about it as well. Open-ended class. Open-ended class, what we do in the lower limit of the first class and the upper limit of the last class are not given. Lower limit of first class and upper limit of the last class are not given. Are not given. How come? Take again marks, number of students. Okay, I'll start with below 20, 20 to 30, 30 to 40, 40 and above. This is the shape of an open-ended class. Okay, you see the lower limit here is not known. The upper limit here is not known. Below 20 and above 40, if there is anyone, it can be included in this very particular class. Whether it is in the category of 70, 80, 100, 110, 150, doesn't matter. If it is above 40, will be calculated in this or put into this very class. This is the shape of what is called as your open-ended class. So, dear students, now what remains is we know what is frequency, though we have not yet drawn, we have not we just have to do one thing. Let me make a table for you people so that you may get to know what are, I have to explain what are tally bars, how are tally bars drawn, and how is frequency calculated. Then this term will be will come into context. See, I have got data pertaining to any damn thing you can talk about, because what I have to do now is I have to make you people understand what is this frequency, how frequency comes into being, and what are tally bars. So for that I'll do one thing. I'll take some data. Do I have here something in a jiffy? Okay, let us take the marks obtained of 30 students in classes are like, or 10 students in class are like. It will get very messy and long. The question is, following are the marks of 30 students in a class. So on and so forth, represented in this and that. I am not worried about. I'll take the marks 2, 3, 5, 4, 8, 6, 4, 9, 5, 3, 2, 3, 2, 2, 8, 7, 6, 5, 4, 6, 9, 7. I should have taken 10 students. 6, 4, 2, but it will make you people to understand it properly, so it's good. So let us present it in a frequency distribution or frequency form. Okay, we are being asked the marks of the 30 students are given and represent the following data. It's a exactly, it is our raw data. which we have to classify into a frequency distribution. I'll make a solution for it, like marks obtained will be my first column. I'll put certain tally marks or tally bars for it, and that is going to give me the frequency. When I'll do the first one, you will just scream out, okay, I know it. I want to be a bit particular here so that we may make it beautiful and of course usable. So dear students, marks obtained are, let us look into the data. 2 is a many times, 3 is a many times, 4 is a many times, 5 is a many times, 6 is a many times, okay, 7 is also a many times, 8 and 9. So we'll have to extend our table a bit more. I don't care about the beauty of these things this time, because what I mean is to teach. What I mean is that you must be able to do it in the examinations. So we'll put tally marks for the given data. How we'll put tally marks? We'll look into the data, how many times which element has come into being. So let us start counting. Let us start counting. White color, okay. 2, 1, 2, 3, 4, 5, 6. So it is 6 times. 1, 2, vertical lines, bear it in mind, put vertical lines properly. 1, 2, 3, 4. Then 5 will be like this, and this will be your 6. So frequency is 6. Is it easy? Just complete it. I'll complete it also. 3, 1, 2, 3, 4. Okay. 1, 2, 3, 4. 4. 1, 2, 3, 4, 5. 5 is 4 times. 6 is 5 times. 7 is 2 times. 8 is 2 times, and 9 is 2 times. It is 2, 2 and 2. This is your total, and this is how we see whether we have done the things right or not. 6, 4, 10, 15, 19, 24, 26, 28 and 30. Our answer is correct because we had 30 students. We had 30 students. That is how a cumulative how frequency is obtained. This frequency can be converted into cumulative frequency. That is why I did all these very things. Okay, let me take it a bit side, and I'll show you cumulative frequency here only. So cumulative frequency is CUMULATIVE, cumulative frequency. Okay, it is shown with by CF like this. Let me extend it. The last element of your cumulative frequency must be equal to the total of frequency, then your answer is right. And how to define cumulative frequency? It is obtained by successively adding the frequencies of the values of the classes according to a certain law. Okay, successively adding the frequencies. Successively adding the frequencies means, what does it mean? It means 6 will be as 6. 6 will be added with the 4, 10 will be added with the 5, 15 will be added with the 4, 19, add with 5, 24 will be added with the 2, 26 will be added with the 2, 28 will be added with the 2, that is 30, and 30 is equal to 30. Our last element of continuous cumulative frequency is equal to the total of frequency. That is what we mean by cumulative frequency. I'll again say its definition is it is obtained by successively adding the frequencies of the values. So we added 6 will transfer as it is. So 6 will be added with 4, it will give 10, will be added with 5, will give 15, will be added with 4, will be give 19, with 5 will give 24, 26, 28 and 30. That's what I did, and here we have our cumulative frequency ready with us. So after understanding cumulative frequency, we have the last two things to take into consideration, and I'll stop it here only. That is the less than cumulative frequency and the more than cumulative frequency. For that, what I'll do, I'll say you less than cumulative frequency distribution is the frequency of each class interval are added successively. Okay, well, it is more than, so that means this is less than frequency. Okay, cumulative frequency. And in more than cumulative frequency, the frequency is obtained by finding the cumulative total of frequencies starting from the highest value of the variable to the lowest level. That means reverse of it. How it is done, it will be a bit confusing if I'll just explain it or talk about it. Let us take some example and do it. I'll take marks and number of students. Got it? This is our table number first. Okay, never keep your table without grid lines, please. If I leave any, doesn't matter, but you must not leave in the exams. Number marks are 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and let us stop it here, 50 to 60. This is our first table. This is a very simple frequency table with continuous classes. Let us say 2, 5, 10, 12, 17 and 4. Total will be equal to 7, 17, 18, 19, 29, 30, 36, 50. Okay, so this is data pertaining to 50 students in a class. Okay, let us convert it into a less than frequency. Less than frequency. What is less than frequency? How it is done? I'll take again marks and number of students. Okay, less than 10, less than 20, less than 30, 40, 50, and what is our last? 60. Less than, and less than. Okay, let us look into the data. How many people number, what is the number of students less than 10? It is here, 2. Now we have to see less than 20. How many people are less than 20? Less than 20 means 20 is here. Less than 20 is this 5 and this 2. Both this 5 and this 2. That comes equal to 7. Okay. What is less than 30 then? This 5, this 2, this 5, this 10. That will come equal to 17. Then 12, 10, 5 and 2 will come equal to 29. Then 17, 12, 10, 5 and 2 will come equal to 46. Then less than 60 we will have 50. See, this 50 came equal to this 50. So our less than frequency table is right. Let us make the more than frequency table. Okay. So in more than frequency table, what we will do, we will take the things almost reverse of it. This is our more than frequency table. I am doing it parallelly so that you may understand it properly. Marks and number of students. So marks are now more than 10. Oh, sorry. How it can be more than 10? It will be more than this 0, then more than, exactly. Now it will start from 10, more than 20, 30, 40 and 50. We don't have a concept of more than 60 here. So we'll start at more than 20, more than 30, more than 40, more than 50. We are converting this table into a more than frequency table. It is very important because you have to draw figures on the basis of these tables later on in the next chapter. So learn it properly. More than 0, we know that total number of students we have 50. So more than 10 will be less of these two. Okay, that is 48 minus 5 will be 3. 50 will come here. 50 minus 2, 48. 48 minus 5, 43. 43 minus 10, 33. 33 minus 12, 21. 21 minus 17 remains 4. That is all. There remains nothing else. This 4 came equal to this 4. Okay. This 50 got up. This 4 came down. So our 50 came equal like this and this. And our 4 came equal to this. So that means this is more than frequency table. So this was an extra information which we are going to use in the chapters to come. So here we complete our organization of data. Hope you enjoyed it and hope you understood it properly. God bless you all. Have a nice day ahead.